right, I think we're live, everybody.
Well, hey, Amy. I've been alive for a long time.
But today you get to be live with me. So,
Yes.
welcome, Jeff and Lenny. Thank you guys so much for joining this week's live stream with Skellig. We're really excited to have you guys here.
Well, thank you, and we appreciate Skellig and the partnership that you and the team provide.
Always appreciative of our partner program, and you guys do some awesome work, Amy. So yeah, thanks again for having us on the live stream today.
Awesome. Thank you. All right, Jeff, what are we talking about today?
Well, you invited us. What are you going to talk about today?
Well, I've heard you talking about this fun little thing called UAF. It's kind of the buzz on the street. So
Yes.
maybe really quick, we could talk about like what is this? What is the general theme of that? What are you guys thinking about over at Flow?
Sure. So the University of Alaska Fairbanks Fine Engineering School. It's actually it's the hardest thing about searching for UAF is not to get the University of Alaska Fairbanks. Yeah, so thanks for having us on. I'd love to introduce Lenny, if you don't mind. Lenny is our customer success officer. He ensures that our partners and our Flow customers are successful from planning to implementation to the long haul. And he's got an incredible family. He's just immigrated. He just bought a house. Lenny, what is the most exciting thing that's happened to you in the last year?
In the last year, sure. No, being on this live stream now, just kidding. Well, other than that, yeah, quite a lot of changes in my life. As you can hear from my accent, I'm still trying to get a proper Texas appreciate going. So moved all the way from Johannesburg, South Africa, situated now in Austin, Texas with the Flow team. And yeah, looking after our channel. Great to have met Amy and the team at Skellig. Really a bunch of top engineers in the pharmaceutical space or life sciences space. But other than that, I think that's probably the biggest thing, Jeff, is just getting all my stuff on a boat and sailing it all the way over the seas to good old USA. But it's been good. It's really been good. Really appreciate the opportunity that's been given to me. And looking forward to what the future is gonna hold for us this side, especially in the North American market.
That's right. Well, it's Lenny is a crucial part of our team, and I have the joy of I have the joy of being able to work with you on a daily basis. I appreciate that. So, but Amy, we're talking about data, and let's talk about data. Let's talk about what most organizations, large organizations, are trying to do with their data. And from our experience, I think if we take a large life science organization, we could really kind of break the persona of data user down into maybe 3 different categories. We've got one of those categories being operations. That's our plant management, it's our engineers, it's our operators. And if we think about their needs around data or information, it's very precise. So we're talking about milliseconds to maybe aggregates of weekly, sometimes monthly reporting. They're using that data for diagnostics, descriptive, really type of analytics. Why did something happen? Cause and effect, root analysis. They're super detailed in the relationship of equipment to other pieces of equipment or process to other parts of the process. That's their need. And I think that's probably a good overview of that group. Then we have the more of that enterprise or executive group. Lenny, in your experience, what type of needs do they have? What type of data do they care about?
Yeah, so if we move up into the kind of the hierarchy of where these people normally sit in the organization as well, the time frame of what they are looking for also kind of increases or expands. So instead of milliseconds or second or hourly data, they're more worried about KPIs and that's going to show them if their initiatives are actually bearing fruit. So they typically look at things from daily, weekly, monthly. So they move really into that high kind of time frame for the KPIs, because that's what they need to focus on. They need to make sure that whatever business decision they made and implement it from a strategic perspective outside of the business is actually bearing fruit. So you can see that KPI going up or down, whatever business strategy they try to involve. So it's not necessarily, getting into the nitty gritties of the actual, data points. It's much more distilled. It's less data. So it's only a handful of KPIs that they are wondering about. And it's also getting data from typically the ERP or the other business type systems in conjunction with the data from the operating side, because we're now looking at cost to get into this as well. So we know what the total production is from the bottom up. We know what the cost is coming down from the ERP system. So we can now create metrics and KPIs around cost and intensity calculations around what actual piece of product actually costs. So it's now moving into that kind of wider time frame to assist them with their initiatives and helping them to make sure that they've got good, proper data to make sure that their initiatives are steered into the correct direction.
Yeah. And then maybe what's that third group? Our data scientists, our data analysis teams typically probably wear more of that enterprise seat, but we're seeing them bleed more and more into the actual facilities. But that group, well, man, they have a hodgepodge. They have a variety of needs, but it's typically very focused on a specific use case. They are tackling some type of a problem, and they are going to want to use ML or AI methodology. They're focused on a different stack of the analytics portfolio, right? They're not worried as much about diagnostics and descriptive. They're looking at predictive and prescriptive.
Yes.
What is likely to happen? Predictive. Prescriptive, what action should we take based on our organization's goals and desired outcomes? Very different, very different. And their needs, the tools they use, everything is different. This is really, I think, that next generation of data pioneer, if you would. How do you serve, Amy, those three different communities as an integrator or as a vendor when you have such vastly different needs with one architecture or one tool or one process?
Yeah, I mean, that's kind of the golden question we get asked every time. Because traditionally, people everyone's kind of navigating towards the UNS. So they're thinking MQTT to get going, but the question always comes up, well, what do we do with the historical data? And unless you actually understand a clear strategy, you're going to default back to point, unfortunately. But luckily, I think we all know of a much better way to go into that, right?
Yeah, well, we think we do, I guess, right? It's all theory in a way. We're all going down a path of transformation that involves new strategy and moving forward, checking the wind, adjusting our sails, all of the metaphors. But the reality is, look, nobody really knows. But what's important is that what we do is measured, metered, and is agile. What we don't want to do is lock into any type of a strategy for the next 10 years, because we've learned that we are taking part in a market that demands the ability to quickly change and to pivot. And so for us at Flow Software, we really stepped back and said, if we think about those three different personas, which group do we feel that we are most interested and capable of serving? And for us, it was really all about operations. We want to help promote inside of the operations team the role of citizen developer. We want an engineer. We want a manager. We want a team to be able to feel like they have access to the data they need. They have the tools that are necessary for them to take that data and turn it into something that they can trust, that they can take action on. And then ultimately, on top of that, we want to provide the business a way to govern that work and reuse it, and a way for the enterprise to request that data, that information from them in a very succinct and automated way. And so maybe if it's okay with you, could I walk through a couple of PowerPoints that maybe just overlay what we've seen, the problems, how a UNS plays in, and then some considerations to make around a UNS.
Sounds good to me.
Okay, well, thanks, Aaron. If you had said no, we were going to have to pivot pretty quick. Okay, great. So what have I already described? I think we've already been talking about this concept of an operation teams need to be able to look at all of their data from various data sources in one unified model. Then have the capability to take that raw data spread across multiple silos and transform it into something they can take action on before then distributing that information, not just within the plant, but outside to other team members as well. And from the business perspective, if that's what my operations teams are doing, I want to govern that process. I want to know that my site on the north side and my site on the south side are talking about the same KPIs, and those KPIs are being calculated the same way. And I'd really like to extract that information after it's already been processed and use it for site-to-site comparison or for enterprise rollups. So that's really the goal of what we want to do. But before we can do all that, we have to understand how we've done this. And the good news is we've spent, as an industry, 30 years doing database management. Data management means investing in how do I put a sensor on a piece of equipment? How do I collect data from that sensor? How do I store that data? And then how do I interact with that raw data? How do I make decisions based on that raw data? So think sensors, think OPC servers, think MQTT brokers, think historians, SCADA, and trending packages. That's really data management, and we've got 30 years of doing that. So we have produced systems that have vast amounts of history in them. And in your industry, Amy, you've also spent a lot of time with those systems, validating them and making sure they're compliant, right?
Yep. And the catch is can't change them. If they're Alcoa, right, it has to be the original contemporaneous value as it was. You have to keep that forever.
That's right. That's right. It has to be auditable and non-fungible.
Yes.
Is that right? All right. So, but there are certainly things and applications and people that need not just raw data. What they need is to take that raw data from multiple places and make sense out of it. And there's a process for that. There's a process that's been true and tried. This isn't anything new. But what do? Well, they say, hey, I've got a group of subject matter experts says I have a need, I have a use case. I'm going to pick from my stack an application, and I'm going to figure out where the data needs to be pulled into that application. So I'm going to essentially start to run a process. That process is pretty normal. You connect, ingest that data from those systems. You then put the right amount of cleansing to that data. So, well, I have a clamp on this sensor. I know it can never really be more than X. And so if it represents as more than X in my data, I'm going to take some type of action on that. And I'm going to bring it back, or I'm going to nullify it. I have data values and OPC quality scores. I'm going to null or zero a value if the score is not 192. These types of processes. Or I'm only going to take a segment of data based on when a machine state was between X and Y. So standard cleansing operations. Now the data is cleansed, it's normalized. I've got data that's come from different systems represented in a standard way. Now I can start to add operational context. So what's upstream of this piece of equipment? What's downstream? What was the lot or the batch? Who was the operator? How long from beginning to end? And that context allows me to then identify events within my data. when pH has changed by more than X% over Y period of time. Might be an event. Now that those events are identified, I can then take that cleansed raw data that's got context and I can begin to aggregate it into some type of indicator. And that might be an average, it might be a min max, it might be some type of a deviation or variance of a population. But now with that input, or I'm sorry, that output, I can validate the results of my process. That is taking the data and making it actionable and then distribute the information. It's a lot of work to just get a KPI on a dashboard, right? Lenny, from your experience, how much code is involved in that process? How much scripting?
Well, it depends. It depends on the business use case. It depends on how much you need to actually achieve. But normally, depending on what tools you utilize, depending on how you actually get the data, if you do this yourself, there's quite a lot of coding involved. I mean, you need to think about a lot of things, right? You need to think about, okay, how am I going to get the data out of the historian A, B, C? Might be different connectors, different queries, different ways to structure the data. Then before you can clean it, you need to make sure that you align the timestamps or normalize the data before you can do that process. Then you need to write your cleaning rules. When do you want to clean? How do you want to clean? Do you look at ranges? Do you look at a band? Do you look at the previous value? Do you look at a spike or outliners? And then you need to add the context. Now, the context can be as simple as an hour, a day, a shift. But what is it? I always ask this question, and people probably say I'm crazy, but what is a day? Is a day from 7 to 7, 6 to 6, midnight to midnight? Where does the definition for that live? So now you need to have another place. So you can see, depending on the use case and how much you need to contextualize and add and clean, the code base currently, quickly stack up. So especially now, if you want to overlay it with events, metadata from those events. And then validation. I mean, how do you trust now what you've done? How do you track back your steps to try and understand where in this process did something go wrong and how do I introduce a change to something new? So it's quite code heavy if you want to try and do this yourself. Not saying that you can't, but it is quite intensive and code heavy.
Yeah. In fact, many integrators and service providers have made a business model around doing this for 15, 20 years.
Yes.
Amy, you've probably been at facilities where there's some report or some spreadsheet or some application.
Factory guy, that's all he does. He's the report. Yeah. Yes.
Or that man or woman is no longer associated with the end user. It's an old integrator that's no longer involved, and everybody's scared to death to even look and open up the thing that has been built because no one understands that code base. We've developed products essentially inside of applications that have to be maintained and managed in order to go from raw data to actionable insight. And I think a bit more scary than we've developed a product is we've developed many products, because every time there's another use case, another subject matter expert or group says, well, no, I want to do this over here now, and I want to do this over here, and I also have the need to stream this and put this on a dashboard and communicate this. Well, we've created many different versions of this process, spread it across all of our applications, across all of our sites over 30 years, and it's created a nightmare. Distributing data transformation has some serious harm to the scalability of somebody's digital transformation strategy. It's not going to scale. I can't govern the definitions around how I do this. I can't govern the process. You would never produce a good like this on a manufacturing floor. You just wouldn't. You would standardize and you would govern the process from line to line. But for some reason, we haven't done that yet with how we go from raw data to usable information. All right. So Amy, the industry says we think we have a fix. This is where I think the unified namespace really starts to help us move towards a solution. And so for the last, really, I think probably 10 years, the concept of unified namespace has been, I won't say prevalent, but it's been growing. And now in the last 3 years, it's been top of conversation, right? So we've identified a few things that we would flag and just say, hey, let's talk about this and think about this from an architectural standpoint as it is appropriate from a data processing strategy. So real quick, unified namespace, let's do that high level review. It's the idea of putting a broker in the middle of those things that are publishing data and those things that want to subscribe to data. And ideally, most things would do both. So most things would push data into a unified namespace. And if you're subscribing to a unified namespace and creating any type of a new result, you would turn around and publish back to the unified namespace. So from a very simplistic overview, let's just say that we have a broker in the middle of our things that are producing data and our things that are consuming data. Now, kind of the first flag on this architecture to think about is that if I'm in a brownfield situation, I've probably got a lot of legacy systems that may or may not speak the required new technology to enable this architecture. So I'm going to have to either replace or I'm going to have to purchase middleware and then integrate to do some type of data ops conversion to go from legacy to UNS compliant. So I'm going to make an investment. It's also a bit of a massive task to say, let's grab everything and get everything here. So this is going to have to be a very long staged operation or a considerable amount of time and budget to go and do this initially. What are we actually moving through a broker? The majority of time, what we're moving is the last known value. Now we are taking the data as it is being created at the edge, and on change, we are restructuring it some and adding context. So we're adding context through the naming structure, and we're adding context by adding properties associated with the data where possible. Again, a lot of this depends on the underlying technology and what you have to work with. But at the end of the day, what I'm really getting here is contextualized last known values from some type of, typically a hierarchical view. So I'm getting a single view unless I'm publishing data multiple times to support multiple views. And that is lightly contextualized. So what about history? If I want history, I would have to go back to the older architecture of doing a point-to-point connection back to the source of the history. Otherwise, I'm only getting the most recent value, and that means I'm either historizing from the day I start at the subscriber side. Don't love that, because then I'm creating a secondary database for all of my different subscribers, which means they have to have the ability to not just subscribe, but also store, duplicating a lot of data. Or I'm going back and doing point-to-point integration, or the more recent conversation, I'm trying to figure out how to publish batches of history as well as last known values through the broker. It's a lot to talk about, a lot to think about, but probably not the best architecture to go back and do point-to-point connectivity. What about my process of executing from raw data to insight? Where does that live? Lenny, you made a comment earlier when I asked if it could live at the broker.
Yeah, no, broker is just a post box. So imagine your typical post box with a whole bunch of little post boxes in it. Think about that as a topic within the broker. So it's a whole bunch of places where you can go and deliver a message, a letter. You open up that topic or that post box, you get the message out, and there you go. So that's what a broker is. It's literally a mechanism to just post a transaction and receive it from anybody that's subscribed on that same post box or topic in this case. So the broker is not a place where we can go and write rules to clean, to aggregate. Well, definitely not to query historical data to aggregate. So it's definitely not the space for that. So it needs to live in an application, Jeff. In your example, does it live on the consumer side, or does it live on the place where the producers or designers live, or in these individual applications?
Yeah. And the reality is, like, you brought up a great point. I haven't even on the producer side demonstrated the pre-processing of data that you might try to do on top of a historian. So Canary or OSI Soft gives you that calc or event capability. So there I would even have more processing that's being done. And I would have even more point-to-point connectivity as I try to bring relational data in to help cleanse them. I think we can kind of agree that this isn't the ideal architecture. It's not what we're looking for. While we have embraced the UNS concept, we've just inherited the mess that we were already used to. Oh, and as I have these new insights, those things that produce those insights also now have to integrate back into the UNS. If I'm not publishing results back, I don't have a unified namespace. And so more integration work, more middleware potentially. Okay, so everybody out at home right now or at work is probably saying, well, Jeff, come on, this isn't the architecture. We know that. That's where the data lake comes in, right? Well, yeah, the data lake solves a lot of those problems. So let's talk about this a bit. I could just say, no, look, from the time I connect everything to the unified namespace, I'm going to subscribe from the data lake, and I'm going to replicate all of my stored data from my sites, from my enterprise into the data lake. And now this will be my single source of truth for my history. Okay. Let's say that let's say money's not the problem, right? We're not worried about budget here. So let's just talk about it from a strategy. Does this make sense? Well, it does solve that problem for sure. Now, depending on your industry and depending on your strategy, you may be okay with duplicating data in the data lake. It may also be a potential flag from a regulatory standpoint. That's for you to know. What about, where does this work live now? Can I govern the process of transforming my data? Well, I can, because now I can put it in the data lake. And I've got an entire team of men and women straight out of uni, a lot of them, right? With all kinds of really cool tools that are IT focused, that they can now use to transform raw data into actionable information. There's only one problem with that. Where does all of the knowledge around the context of that raw data and operations and process live?
All the way back to source, Jeff.
Yeah. Amy, you've got a lot of plant experience. Who knows the most about the process?
It's always the people on the plant floor.
Yeah. I had someone recently say the steel-toed army or the white bucket sitters. The outside of life science, right? All the other industry, we've got mandates for steel toes and a lot of makeshift stools on the turning white buckets upside down. The hard hat crew, right? The front line. How do we get their knowledge of this data into the data lake? Well, it's simple. We just let them connect to the data lake, and then they take their data lake tools that they're so familiar with, and they go work in the data lake. Well, that's not happening. It's never going to happen. IT's not going to allow that to start with. It's a different set of tools. It's a different knowledge. It's different experience between what operations is good at doing and what the data teams are doing. So how do we get the context from operations into the data lake? I think for the most part, we don't. I think we can get some. We might even be able to get half, but we're not going to get all of it. And the point is to try to get all of our knowledge into one place when possible, right? So let's take the work that we are able to do. Maybe we get some OT input if they have time. Maybe we figure it out. Now we can distribute from the data lake history on demand. Our applications and our teams and our users can just hit the data lake. They have access. We can build pipeline. We can build automation, and we can move as we need to. But still, What about the OT folks? What about the men and women that actually could change this quarter the production of our facilities, right? They could be more efficient. We could be safer. We could have higher quality. How do we enable them to be citizen developers? Well, we do it by building a report factory, another team to support that team, and then we ask the OT folks to make requests into the report factory for the information they care about. We haven't seen this be very successful. You're going to make OT ask IT for access to data that they produced after asking them to help contextualize that data and then deliver them results, probably not at the time frame that they're happy with, and probably not with the accuracy they demand. And sooner or later, they're going to say, no, we don't like this. We're not going to ask. And they're going to look over their shoulder. They're going to say, oh, that data that we really wanted access to, well, we know where that lives, and we've got a tool that will let us query it. I'm not picking on Excel. It's just the fact that everybody knows how to use it, right? So they're just going to make SQL queries. They're going to use some Excel macros. They're going to figure out how to go get this data. That's why they're such good operations folks. They're resourceful. This just doesn't help solve the problem, though. We lose out on that context, and we're not really giving them the right tool set to be citizen developers. And so that was the kind of the quandary that we found ourselves in, that we wanted to try to solve and help answer. We want to take this architecture and extend it and make it more powerful. This isn't a message of don't use the UNS. It's not a message of don't use the data lake. Those are great strategies. The question is, do we recognize that we have 3 different groups of men and women that we need to serve their needs from an information management perspective? We definitely recognize enterprise. We definitely are recognizing data scientists and analysts. Are we recognizing the operations teams? And if we're not, we're missing a huge opportunity to go after the low-hanging fruit that still to this day hasn't been solved because just giving them a batch report is too difficult. So here's the architecture that you asked us to really discuss. And I'm sorry, 30 minutes in, we're just now getting into the architecture, but I hope there was value to the audience to think through the strategy that we've been going down. It's a good strategy. It just needs one minor tweak. And we're going to take a chapter from the UNS to solve this. We're going to say, what if we take the concept of a broker and we just double down on that broker? So we will focus on real-time data into the UNS. Now look, don't look at what lines are drawn here as the gospel and what should or shouldn't be connected. That's not the point. The point here is just to say, maybe I don't have to connect everything to the UNS just to be able to pass real-time data, because not everything fundamentally from day one cares about real-time data. Maybe over years, the strategy will be almost everything is connected, but I shouldn't feel like I have to do it right now. I should start small. Connect the things that add value and move the data to begin with. But what about the history? What about the process of analytics? Let's build another broker, another hub, if you will. And let's put it somewhere in between, just like we have the UNS, so that both on the OT side and the enterprise side, we are able to engage. And this is what we call the University of Alaska Fairbanks. This is the Unified Analytic Framework, the UAF. And it's the UAF, or as I've heard some people say, the UNS Plus or the Uber UNS. Yeah, look, I don't care how you draw the circles, but this concept of how do I give my historical data? How do I give single point access to that historical data? How do I unify all of my history into one system? How do I have all of my real-time data flowing through another system? Where does the work of processing this data live? It doesn't live in a post box. It needs a series of engines that will help, one, build a model and then execute that model and give me my OT insight. So I need a system that OT will use daily, because when OT uses it, they're citizen developers. They can self-serve what they care about. And I get the context and that intimate knowledge of the process encoded inside of these models that get built. So it's great for OT. It gives us a centralized place to process data and have it ready to work with. and it provides all of the engines that actually do those transformations. So I'm not just modeling data, I'm actually taking that model and executing the calculations in that model. So I'm coming out with an events database, I'm coming out with a KPI database, I'm coming out with all of my rules on how I cleanse data, my structure, my attributes, it's all there, it's all stored, and it's all available. It's available to publish into the UNS on change. So instead of having to subscribe only to raw data, I can also easily now subscribe to the last known value of a processed variable, and I can distribute it as well for history. So there's a database inside the Unified Analytic Framework that I can now query if I'm an application and say, oh, I see you have 1 hour averages. I need the last 7 days. Or you know what a batch is. Give me all the details for this piece of equipment for the last 10 batches. It's queryable. It's also highly governable because all of my work and my transformations in that model have been templatized, and I have one body of work that the business can focus on. So that means I can take work that's already been done and apply it to other use cases. I can apply it to other sites. It's not code heavy. This is actually a low code environment. Code is discouraged. We want to do things in a way that OT teams are fast to value. So we don't write code. We don't write scripts, as I think you'll show later on. And then the last piece is, what about my data teams? The data teams need more than just pre-processed data. And maybe not everything has arrived at the data lake. Maybe systems over here on the far left have raw data that hasn't come to the data lake. Well, we've probably already connected to those systems because OT is going to connect almost everything as they build out their use cases inside of this framework. Well, data teams can look down at underlying data sources and they can say, well, I know that data historian and that qualities, that LIMS system. I know that they have data I need and care about, but I don't know how to interact with them. I don't know the right type of queries to make. I don't know how to interact with that specialized time series database. The data teams can just query the model because the model is aware of those data points. They're associated like tags. And the data team can say, hey, in the model, you have this model about these tags. Can you just go ask the underlying data sources for the raw data for me? And that's exactly what the UAF does. The UAF says, I have a query that's asking for pH and it's asking for some of the quality results. I will go ask the underlying databases for that raw data. I will package it into one payload and I'll return it to my client. And so, Amy, that is an overview of the UAF, but I think it would be best maybe if we kind of showed it in action a little bit. And if I'm not mistaken, you've been messing around with this a little bit.
I sure have. Yes. Thank you, Jeff, for that overview. I think you explained it really well. So I did prepare just a few small examples to try to illustrate some of the big points that we talked about today. So let me share my screen now. Okay, so today I have just 2 examples that I want to show. So the first one is this, and they're both tailored for life sciences, obviously. So the first one is this CO2 screen. So I'm pretending that I have some mass flow controller on my bioreactor, and downstream of it is a totalizer counting how much CO2 was added. Because, some bioreactors do use CO2 to regulate the pH. Now, one thing to mention really quick, what's cool is the data here. I don't actually have a bioreactor, sadly. This is actually all coming from Flow's native simulator. So that's really neat because if you download the platform free trial, those are awesome. You can start building things right away without having to actually access any data. So there are 2 images on the screen. Now, the bottom one, it's intentionally bad. It's a very zoomed out trend of this totalizer. Now, I did that because if you are in the life science industry, I know for a fact you have some kind of time series historian, and you're probably dealing with trends like this all the time. But what I'm trying to show is that there are limitations with how much understanding you can get from just viewing raw time series data. This looks like a flat line, but if I hover over it, I can actually see it's changing a bit. What's cool is I can actually click on this and actually get the details of what the value actually is along with the history. And a really common use case in life sciences is we need to know how much gas is totalized. Or if we're talking about our filtration skids, we want to know how much product went in, how much product came out, how much waste came out. And that is a hard question to answer when you're looking at a flat line. And so on the top of the screen, we're showing how when we use KPIs, that exact same underlying data becomes useful information. So what I did was I just used an hourly KPI to see how much was being totalized per hour. And the really cool thing is this was like, I'm not joking, like a 2-minute effort to build. So really quick, I'll show you the back end.
Maybe just before you go in there, Amy, if I can just, sorry to interrupt very rudely, but I think you guys can also understand what we say was the last real-time value living on in the UNS versus a KPI or aggregated value complementing the UNS. Amy, if you just hover right to the end of that totalizer value, I mean, if I'm going to, the bottom one, the raw data, if I'm going to push this value to the UNS, I'm going to give you a value of 64,000 for argument's sake. Okay, what does it mean? Your current counter value at the plant floor is 64,000. Okay. And if you missed, and if you can tell me, Lenny, you're talking nonsense because I could have gotten the previous value and I could do the subtractions. Okay. First of all, where do you do it? And what if you only subscribe to that UNS now? You're not going to get the previous value that's been pushed. You're getting the current value of where it's been pushed. So it's just showing that little bit of, I know it's a great example, but it's showing the difference between pushing just a real-time value as it changes and actually contextualizing that value, in this case, very simply to an hour and giving you the actual, this is what I actually produced for the past hour, not just the real-time value from the counter value that we post.
So Lenny, the pushback would be if I'm putting on a UNS badge. The pushback would be, I'd say, hey, Lenny, I would just go to the edge. I know I need the delta, right? We all know we need the delta. We might also want the hourly. So I'm just going to do that calculation as well and publish it to the UNS. Well, I'm going to raise that as the solution. And then I'm going to say, yes, but now you've just done more data processing and transformation somewhere else. That's exactly. Not, and I'm going to do this 20 times, 20 different places, and I'm not going to cover that.
Yeah. It's not shared. It's not governed where you do it at the edge. The edge is for me a place where it needs to handle control. It needs to make sure that it controls and alarms and shut down and interlocking and have all of that good stuff. The edge for me is not a place to try and do data manipulation. It's my view of it. But yes,
I'm a little looser in my view, but that's okay. This isn't, it's like there's not, again, back to, I think maybe our opening. We are humbly submitting things to talk about as a group, right? Because I think you could do a little bit more on the edge. But again, I have to have a way to govern all of that.
Yeah.
And
right. It's frustrating if you do it at the edge at one site, but then the other site doesn't benefit because their edge devices are not connected to your edge devices.
Yes. And another question, Amy, if at the UNS I had some calculations arriving, how could I know I could trust it?
Yeah.
I have to assume. I have to assume the engineering's right. I have to assume that there's, I can't probably see the expression. I don't know necessarily the rules on if that data was cleansed or how it was cleansed. Where's the documentation?
Yeah. So to that point, let's actually show what the simple use case looked like in the background.
Thanks.
All right. So if we hop back here, all I did was, as I grabbed it from my simulator, I just have the present value. And to get this per hour, I just dragged it onto the H for hour. And then, like you said, Jeff, I aggregated for delta. Done. That's it. If I want to make a chart, it was super simple. I just go to the chart. I say, right click. I want to make a bar chart. Drag it on. And that's it. It's very friendly to OT people. It's very low code, no code to do really powerful math, which is something that I really appreciate.
Well, and
Now,
even if that counter was one that randomly reset from time to time, you
mhm.
could, instead of using the delta, you could use an aggregate that would actually watch for the reset and do the math and catch it.
Yes, that's a great point. Something cool about Flow is because it's tailored towards the OT side, it is very granular. So if, like you were saying with the counter, if it did reset, you can put in the value like, oh, just know it resets at this value. So you don't lose those few milliliters during that reset, because it's not like it's a 5-second interval. It's real time, very specific, very accurate. Pretty cool. So there's actually one other screen I want to show as well. Let me navigate on over. Okay. Now, this screen was not built with any of Flow's simulator. This screen was built with a fancy proprietary DCS system that I cannot name, but I know a lot of people in life sciences, they are using it. So let me explain what we're looking at. The top one is just kind of the state of my reactor over the past 12 hours. So I decided that it would be helpful to see if it was held. So I did red, because traditionally with batches, things hold if they're an alarm. So something's gone wrong. I did green if it was running, and then it's gray if it's just hanging out. Now, what I like about this is if you look at this quickly, you get a sense of how things were going. So imagine if you're an operator coming in for a new shift. You can just look at this and right away know, oh, okay, they were clearly struggling at night, but then pick things up and oh, they're struggling now. But the other thing though, is this is life sciences. So just to explain how it's working, it's giving you the state per hour, so hour chunks. So you can see over here, like 15% of the hour was running and then 85% was held. In life sciences, though, we do everything in batch. So maybe you want to know, well, what was my running, held, not held per phase? What's really cool is the Flow platform can do not just basic time interval aggregations, but it also can do event aggregations such as the start and stop of your phase. And so I have that displayed right here down below. Now, honestly, this was a very simple, easy thing to build. I think everybody watching has the capacity to be able to build this.
With the demo license, actually, I think.
Oh, right. No, I wish. Oh, but here's my question. How many people actually know how to build this? How many people watching know for a fact exactly where I went in the back end? They knew what I grabbed from this proprietary system that I can't even name publicly to make this possible. The answer is a very few. And in my experience, the few who do, they have their hands full keeping the process going. So they're not thinking about stuff like this, stuff like KPIs, because it's so hard to get your hands on a legal license of this system. The people who have time to think about data, think about KPIs, probably don't know how to get it. And I find that unacceptable, because if people cannot access and leverage historical data to solve problems, they are being inefficient, and that cost is being paid by the patient. Now, as we said before, what's exciting, people are starting to turn towards the UNS to get access to their data. And if we're being honest, we're using MQTT, right? And that is a great start. And I do want to point out, the Flow software platform does strongly support integrating with an MQTT-based UNS. Actually, what I can do right here is I just actually published out all these KPIs over MQTT. So we have our CO2 stuff here, we have our batches. I put in UTC time, so that's great.
So Amy, if I could just ask a point of clarification. So when you were saying who has the ability to do this and how would you get the license, you weren't actually describing Flow. You were talking about that proprietary.
DCS, this is correct. Yeah.
You're leveraging, you're saying, why not just use a tool like Flow or something else that embraces this capability to be able to connect to these various systems, because it may not be the same legacy system everywhere, but Flow stays pretty agnostic. So you could just build this at Flow and then report.
And then anyone can access. Yeah. So where I'm going is, traditionally, if you're going to do the Excel way, only a very rare subset of people would know how to build a screen and then be actually have the time to do it. However, if you end up using a platform like Flow, this suddenly becomes very accessible to almost any user. And that solves the problem, because the thing is, everybody has all of these historical tables that are validated. The FDA is not going to let you do a SQL update that says, hey, rename TT07 to inlet temperature. Not happening. You have to keep them the way they are. And so the way that you can democratize that data so anyone who has the right permissions can easily reach in and grab it is by doing this unified analytic framework approach. So for example, if you were going to use Flow software, what you can do is in the back end, you essentially kind of do your data modeling over here. And if I'm honest, this looks a lot like how you would build the UNS. I see the semantic hierarchy, I see tags. But the big difference is every tag here has access to all of the historical data behind it. And now anyone can reach in and grab it if they use the API. Now, if API sounds like a scary word, do not be afraid. Again, huge props to Lenny and everybody at Flow. I have literally never used an easier API in my entire life. So if you want to use it, you can come over to deployment. You just right-click, open link. And it brings you to this page, assuming you build the key, right? So build the key, open the link. You can start using this just by pushing buttons. No code, no Postman required. So I think I'll just show high level. There are some really cool things you can get with the API, almost anything, honestly. You can learn about the configuration. You can learn about the data. You can learn about information. You can learn about the model. So we'll do a few just as a quick example. I know that in my example, we did have an enumeration. So to try it out, I can just click execute. And look, it tells me, yeah, you do have one enumeration. ID is 1. That's what it's called. If I want to know, okay, what was inside that enumeration, I can just click try it out, type in that ID we just saw, click execute, and I can see, oh, okay, the number 3 corresponded to the phase SCR, XFR, pH. Very, very cool.
Kind of our goal and mandate is that nothing you put into Flow gets left behind in Flow, right? Like everything with this API, all of the attributes, all of the context that an engineer might build into this tool, the organization now has access to that. And that's how we're trying to empower the enterprise and the data scientists and analysts, because all of a sudden it's like you get to open up an engineer's head and look inside and say, oh, I see what you're doing here, and pull that information out.
Absolutely. And definitely the coolest part is you can get the data. So again, pretend I'm looking at, my UNS and I saw, okay, cool. I have a running measure, but it's only giving me the last hour. But I want to know over the course of a few hours, what did it do? And so what's really cool is you can actually type in the API that range of time. I think it was in this one I filled it out. Expand. Yes, there we go. So in here, I can specify, well, I wanted to know between 5 and 9, what were all those values? Put it in the measure ID. I hit execute. And you can see it actually returns this like giant JSON, all of these values. So now you don't need to know that complicated proprietary backend to be able to access that data. You just need to be able to use this button pushing API.
Well, and what we would probably even recommend would be when you're publishing back to the broker, for instance, so back over on your MQTT Explorer, when we're publishing that hourly measure, we could also be publishing what its ID is.
Yep.
You could be publishing even if you wanted a property like a URL of where the history lives, so that I could just query that URL right out of the
There you go.
UNS. And then you see what I mean? Like we can just say, oh, well, there's where I get history from. There's the endpoint. If you put your integration efforts into something centralized, everybody will benefit is what we're trying to, the idea we're trying to express.
100%.
But what if I didn't? Okay, but what if I'm a data scientist? And yes, thank you for pre-aggregating data for me. That's helpful. I appreciate that. But I do need some raw data that's down inside of that proprietary system that typically, well, you would write SQL queries to, or you'd have to have some type of Jedi knowledge about how to interact with it. How do I get there?
Absolutely. So what's really cool is within Flow, those raw data are actually called tags. So the measures are their aggregations. The API supports querying tags, which means it hits that raw database. So if we wanted to, we can do one right now. This is actually going to hit that DCS backend database and get us some values. So if I hit execute.
Will you show us while that's loading what you've done in Flow to be able to hit that DCS as a configuration point?
Sure.
Because it's a good bit of, I mean, it was initial work, right? This isn't a magic box that just scans some mystery at legacy DCS. You had to write a query at some point.
Right. And I won't show the whole thing. That way they don't see the table, but you can see the first half. Already lots of words there, right?
Yeah.
Imagine having to tell every single person, oh, this is the really complicated query you got to do in order to just get information about the state. Versus instead, just hit this button here and then look at that. We're actually returning these things completely. Just this is the raw value from that underlying table.
Yeah. And it's the same format. It doesn't matter if you hit data source A or data source B or data source C. What you get back from the JSON response is universal. So it's conformed. So that's really cool because then you don't have to worry from the application that you're using this to actually you cater for different scenarios and different ways that different data sources actually present their data.
Great demo, Amy. Well done.
Yeah, thank you. Well, great platform, guys.
Well, Lenny and the team have built something incredible. And we're really grateful for partners like you and the community, this entire Industry 4.0 community for kind of blazing a trail, right? We're all in a point of discovery right now. We've put a business model together for Flow so that this is something that you can try out first. So there's a 90-day trial. That's what I think you've actually downloaded here. Yep. There's a very small pilot license that you can start like $9,000 and have a perpetual license of the product, or you can then graduate to an unlimited version of this. No restrictions on the number of calculations, the number of data sources, the number of users. And that price is for $14,000 a year. So we think we've hit a sweet spot on the business model. Now it's just a matter of the community saying, hey, we want to give this a shot. And just in this last 6 months of this year, we've picked up 4 or 5 really large life science partners that are starting to do this because they've run into the problem that we've described on the front half of this call, and they're looking for a change. So thanks for helping us highlight it, Amy.
Absolutely. All right. I think we're at time, so we'll wrap it up here. Thank you, everybody, for coming. I really appreciate it. I hope you guys have a wonderful day.
Well, thanks, Amy. And if you wanted to learn more, as an audience, they can reach out to you, or we could do flow-software, flow-software.com. All right. Thanks, Amy.
All right. Thank you, everyone. Bye-bye.